Hello all, welcome to yet another Dev Nation Live. This is Kamesh. I'll be your codecaster today, live from Bangalore. And thanks for joining. Before we get deep into our sessions, I just want to take a quick check to see if my audio is well, my video as well, so that like I can adjust these things before I get started with the presentation. So we'll just take you can just type it on the chat to see like if you receive my signals well, so that like we can just keep moving on. So I could see a few people. I see EVG. Hi, good to see you. I think probably the first time I'm seeing you here, and I also see DLF again. I think this the presentation today will be mostly I'll try to keep it within an hour. Maybe like it might be five minutes based on the questions and other stuff we have, and hopefully we don't have any technical glitches as usual we have. If it all goes well, then we should be done within 60 minutes of time. That's great. Thanks, Ravi. Thanks for confirming that things are good. So let's get started. So all I wanted to do is like just to get started with our master course presentation. So which is what I have today with me. So what we'll be seeing today is like we'll be seeing the basics about Kubernetes. What is Kubernetes? What is pods? And how to get your first deployment rolling. And then how do we get deployed? What are the ways we deploy the cluster either in online or other stuff? So I'll be using OpenShift today for my session. And then all the demos will be run against OpenShift so that you can have the feel of how OpenShift looks like. Um, yeah, I think Asabi, I see there is a bit of lag on my video. I think I can go with that. I think I let me allow it to correct automatically during the flow. Um, that's great. So, and here is our upcoming definition schedule that I have put down for you. So this is basically to tell you like what we have today, coming up in all this entire month of May. So we have the beginner course today. I think we have one more thing on Wednesday. So that's going to be a follow up of the same thing. So be sure that if you're attending this, make sure that you also attend the Wednesday one, because we'll be having some residue left over from this session, which will be carried on to the second session, so that we have a connection and context. So that is what we are going to do on that. That's going to be a little bit advanced, mean to say like how do you build your images, deploy your images, etc. We'll see about the agenda in a second. So on 4th today, so we'll be starting with this session in India time, that's 12:30, and then we also have a session in France at UTC 11 in French, and in Portuguese we also have at 1400 in Portuguese, and then we also have in English that's going to be on at 1600 UTC. And that's going to be all on Eastern time, and then we finish the day with the Spanish one from Alex. That's going to be at UTC 1800. So we also have a day's break tomorrow for you guys to get recuperated with all the things which we taught you guys, and then we can come back again on 6th, the same time pretty much, and then we'll start with the Kubernetes Master 2 session. So that's going to be something like which is going to be there. And the next week, we are going to launch all the supersonic subatomic Java. That's going to be pretty exciting for us to share our Quarkus knowledge with you. And then May 12th, week of May 12th, we are going to do Istio. And then May 13th and May 18th, as we heard you from you people last week, that there were a lot of requests like how do we do other stuff which is more infrastructurally things. So we are going to have two dedicated weeks in May. That is going to be 13th and 18th. So that's all going to be operational stuff, where we are going to teach you how to write operators, how to deploy operators, and more, right? That's going to be there on the week of May 13th and May 18th. And that's going to be the 18th, and in fact 18th and 20th. I'm sorry about the date. The 13th is again a Quarkus thing for us. So this is going to be the schedule. It's at dn.dev/master. I think I would request Sebi's help to put those links on the chat, so that that's there for you. And then let's go further. So what we have further on this is like this about myself. So if you have any questions on this sessions or any other sessions that we take, and you are within this particular time zone, I probably can just feel free to request me. I mean, drop me an email on this email address which I put on there, kameshes@redhat.com. I also put my social handles, my LinkedIn, GitHub, Twitter handle, so that you can also go and debug an issue on a GitHub repository which I'm going to share with you, so that will be kind of help interacting with you as well and answering your questions as well. So that's something which you want to put on there. And with that, so I also kindly requested the survey. That's 2 weeks was excellent. I think I really need to appreciate you guys for taking patience and putting the feedback in. that we have gone back and worked on those feedback, and then we're probably applying those feedback in this week's session. And then I request you again to drop the feedback after the session, so that like it keeps helping me improve and deliver the right content which is required for you people. And also like any corrections or any improvements that we make, that's always going to help us. So please do have this link filled up. Once you have done, I'll also flash the links again, all those links again at the end of the session. So with that, so I'll just share the slide link so that we can follow the slides as well. It's going to be dn.dev slash cube master1. So this is going to be a slide link. I just pasted the slide link on the chat, dn.dev master1. That's going to be a side link. You can go to the slide and then you can just follow that with me. I'm not going to cover the complete slide because it's a 76. I'm just going to flick back to my command line and show you those commands, execute those commands, and how it's going to work as well. The commands are going to be there on our tutorial site. That's called dn.dev slash tutorial. So this is the one. So we are also making some changes to the tutorial as well. So you'll be seeing some changes coming up due to RIL. I think I got the spelling right. So that's going to be the tutorial site. I'm going to follow that up and then put the commands from the site as well. That's what you are going to do all these days, right? So that means a couple of next 45 minutes to probably, I should say 50 minutes, next 50 minutes. All right. So, and then I'm going to paste the survey link as well on the chat. I think I would probably put that at the last so that like you can fill up the survey before you leave from the session as well. With that, so what we have now, right? So this is going to be an agenda for the master course beginner. That's a course you are in right today. So it's a 1 hour thing. So you know that we cannot cover every part of Kubernetes in 1 hour. So we try to make the most crispiest thing, most easiest thing that's going to help you get started. Okay. So after this session, after our sessions, probably the sessions which we have. So if you go back to your machine and then start a mini cube and say cube deployment, you will see the application getting deployed. So that's something which we want to achieve with this. So apart from this, what also we want to do is like we want to tell you why we need these two things, why at all we need Kubernetes. So why Kubernetes is required and what is Kubernetes provides you, right? So that gives you a better context when you're architecting your new solutions, so that helps you to get further. I will talk about a bit of installation. So I'm not going to talk about installation. I'm going to use a cloud provisioned thing, which is OpenShift today. But the tutorial has the installations where you can get started with Kubernetes on your local cluster as well. So that's something which we'll touch upon. And then we'll see about the kubectl, which is a primary tool that is used to interact with Kubernetes clusters. That's what we're going to see today. And then we'll see about pods, replica sets, deployment. We'll see a bit about logs and so on, how do you look the logs of your containers and other stuff. And finally, we'll see how we'll also be seeing service across these examples. So, but we'll also have a dedicated section at the last to see how to expose your application as a service. So this is going to be a broad agenda for today. So anywhere, anytime, keep popping your questions on the chat and I'll be monitoring the questions, or Sebi is there to help me as well. So we'll keep answering your questions and maybe we can take a pause at times to answer the questions and get back to the session, right? Yeah, so let's go here. So why we need Kubernetes end of the day, right? This is a very fundamental question which runs in everybody's mind, right? So everybody's talking about Kubernetes. What's Kubernetes? Like, why do I need Kubernetes? Deploy my application as Kubernetes. So that's because, see, if we see your old school of application development, right? That's where we started with a few years back. Like we have a monolithic application. So since I'm a Java developer, I come from a Java background. Basically do with Java-based application is that we kind of go and make this application as a jar or a EAR or a WAR and take this application and deploy in an application server. That has been our whole school style of application, right? So what happened after that? Like, so we had a brief history. I'll talk about the history in a couple of slides from now. So what happened? Like we started embracing the microservice-based architecture, and now what we felt, okay, this is not the way I need to deploy my application. For my microservices, my application services needs to be distributed, right? That's something which came into people's mind, and people wanted to say, okay, how do I distribute my application? What should be my platform? So initially we started with the computes, right? Initially on Amazon, other kind of thing, where we built up the computes, and then we made the same application server deployed onto the compute and started the server, right? But if you see the true nature of microservices, it also had few problems that we'd say, right? For the first challenge is that let's say an example, like I want to build a jar, all right? So what earlier happened like we have everybody using a different version of JDK, everybody using a different version of some other libraries or dependencies, and this was causing a lot of the problems when the typical thing reaches from dev to ops, right? When ops want to deploy the application, and now I get a problem. Okay, what happens? Like, why this jar is missing? Why this library is missing? Why my JDBC driver is different? I use Oracle 11 or 12 or 13, but now the Oracle is different. So these problems started to arise on each and every case, right? That's where your containerization of application came into picture. Okay, we'll solve this problem, but how? So we'll take the application and containerize the application and deploy so that everybody from ops and reaches production, it's going to be exactly same. All right. So that's the challenge we try to solve with Kubernetes or OpenShift. We say, okay, don't worry about this. Take the application, give my application as a container. Once the application is container, then you can take and deploy this application right into your application server without any, into your platform, cloud platform without any hassle. All right. So this is not only the thing, right, which is solved to solve the problem. I think I have a few more slides for you to read. So this all get out achieved with something like a Docker file, right, which is the first thing where we kind of deploy my application. I write my entire application packaging as a Docker file, give it to the Docker thing or CRIO or any kind of thing. And that's going to, well, that's made your life much easier. But the problem right now, what happened to you is like when I start to deploy or run my application, excuse me. When I start to run and deploy my application, now the problem comes, I have started to face a lot of challenges, right? This is again, moving into microservices also started me to have some kind of a problems, right? Few more problems. For example, let's go and see what those problems are. So these are the typical DevOps challenges. Even after you containerize the application, even after you move to microservice architecture, these are something which you started to face. The first thing is, how do I scale, right? How do I scale my application vertically? What happens when some node goes out of my cluster, it crashes. So what do I do, right? So that is something which we need to start with. And how do I avoid port conflicts? This is a very common problem, right? When I start to deploy my application, let's say on 8080, all right? And then I build one more microservice, which also going to run on 8080. When I'm going to deploy that on a VM, on a compute, now I'm going to have a port clash. That's quite common. And now what happens with the port clash is that once the port clash happens, you go back to your security guys and say, okay, opened up in my firewall. Okay, this is okay if it's going to be 1, 2 or 3 or 4 services, but imagine a case and it's going to be microservices, then it's going to be hundreds and hundreds of services. Now the problem is going to be bigger, keep opening ports for each and every little thing which I'm going to do, right? So that's where I want to avoid some kind of port conflicts. How to manage them on multiple hosts, right? I want to have a distributability of the application. I mean to say, okay, I have a huge cluster. Okay, it's spread over geography for all my failovers and availability use cases. What to do is like I want to go take these applications and deploy the application across the cloud without any hassle. Okay, it should automatically be done. Okay, that is something which, and also there could also be a case where for a dependency application and my application wants to go and sit in the node which has the database where I can do a local host call instead of going over the network for some kind of a performance reasons. So this is also one of the cases where I want my application to be automatically go and deployed on a particular node. And what happened if host in trouble? So this is again a typical problem when you deploy it on the cloud, right? My application, my node may go out of CPU, may go out of disk, or it may go out of even your compute nodes, right? I mean any other resources, right? Disk, memory, or CPU. Now what should happen is like your orchestrator, this is what I'm trying to introduce you right now, is an orchestrator which kind of deploys this application across, deploys these containers across, should take care of doing this thing, handling these things, right? And they say, okay, when my CPU is not good on this node, don't go and deploy. Take and deploy another available node or stop the deployment. Okay, this is something we have to do. And also like how do we keep them running? So this is one of the common cases, since I told you like I'm a Java developer and many of you could be a Java developer as well. So one of the things, the common problem I'll take here is the case like when you zookeeper kind of thing, right? Where the production node zookeeper, they say like always my cluster should have 5 nodes, right? That's what they say for zookeeper. So when one of the node goes down, the synchronization date of the data between these zookeeper nodes will not, if the node comes up and they form the quorum again, right? So this is okay. So momentarily there might be a cases, there might be data loss which could happen. So we want to try to avoid that particular stuff. So I mean to say like, okay, you get whenever something goes wrong, whenever I go from 4 to 3 or 3 to 2, and then have to go back again to 5, right? There should be somebody who should take care of these things and starting to maintain this particular stuff so that it can be deployed in that way. That's what something which we want to do with as well. So which means in the Kubernetes world, we call them as replicas, a desired count and actual count. Okay, we'll come back to replicas in more detail during the demos. Them. This is another critical stuff where I want to update my application without there is going to be a service disruption. What we typically call as a roll. The moment I do a rolling update, my services should not be disrupted, and the consumer should smoothly move from version 1 of service to version 2 of service with ease. All right. And again, how do I rebuild my container image? Is a very common use case. How do I quickly do this so that whenever I commit some code in my GitHub repository or any kind of repository, my application is deployed quickly? Are the biggest most critical challenges that when we move from the age-old traditional old school style to new school style microservices based deployment, this is what we start to face. And that's exactly where your Kubernetes is going to help you out, right? As I already introduced you a term called as orchestrator. Now, what I'm going to talk about right now is an application orchestrator. What an application orchestrator will do is like, we'll see each and every feature of the things, all the constraints which we saw in the previous slide, and we'll see how Kubernetes is going to solve all these problems. All right, so I think I am back. I hope like everyone could see. So let me take maybe a couple of seconds to just everyone start to receive my feed. I'm sorry, there was a slight crash with my streaming program. I need to restart that, so I'm getting back on this. So I'm back. So is everyone able to listen and see me? Thanks, Abhi. I think let me go back to the slides where I was on the Kubernetes stuff, right? Awesome. I'm sorry about this glitch. So the glitches of streaming network. So that's something that's inevitable. Um, what I was trying to say is that so we saw about few problems with Kubernetes, right? Kubernetes, I mean the DevOps challenges that we were facing because of all the other things, right? Containerization, deploying into multiple clouds, and all these stuff. So now the biggest thing what I'm trying to solve is Kubernetes is going to solve you all these problems pretty easily, right? With one platform, I'm going to achieve all these stuff. And now what happens is that, so I'm just giving this about Kubernetes, leave it for offline read. And this is the brief history of microservices, right? Where Kubernetes is going to fit you in, right? If you see Docker, you see microservices defined, and Docker was there, Spring Boot was launched, and Kubernetes was launched. These are all the evolution services developed. I think I'll leave again this for your offline read. And then this is where we did with Red Hat. The moment the microservices revolution started, if you see that it was started in June 2014, what we did in Red Hat in 2015 summit, we kind of launched on the stage. There's a video if you can go and watch this. So it's an on the summit keynote demo. We're able to give even one container on the fly. So which means that we're kind of doing 1,000+ containers on Kubernetes the moment the day the Kubernetes was launched, right? The year, not even year, probably few months from the Kubernetes. That's the expertise we have around Kubernetes that Red Hat is a leader with Kubernetes based deployment, right? So watch the link. The link there is gives you the whole video. You can go and watch that out. That's a very interesting video. I love you. You will love all to watch that. It's exciting for you as well. All right. And said, what's Kubernetes, right? So we'll talk about this, right? The pods. See, this is the common term which you'll always hear with Kubernetes. Every time when you go and listen to Kubernetes, right? So you'll always say, okay, deploy this pod, delete this. These are the common terms which you see in any of those, what's an article or anything, you always come up. So this particular term was taken from the term which means that the pod is a way together at the same term which came from for the Kubernetes as well. This is a typical English word. That's where pod bought from, right? So let me give you let me skip this slide. Talk about a few things, right? But before we go there, so this is the old jargon, right? Any, as I told you earlier, any Kubernetes article you see, my audio. Okay. Let me see my audio. Let me fix. Try to see better now. The audio and visual is not so good. I'm not really sure what's the problem that's happening here. So let me give a few seconds for the pause to sync up so that you get back the audio well. So let me take a pause for maybe 10 seconds. Audio is coming back. Let me check quickly. All right, so is my audio still bad? Is it better now? It's better now? Okay. Let me try to see if I can change. So this is. You still have the same problem? So let me know if you still have the same problem. I can keep talking and then let me see if it helps. So let me go here. Getting better? That's great. I think probably I see there should be something issue with my streaming. That's great. Thanks, Jason. I think that's better. Thanks, Rodloff. I keep moving. So I'll take a pause whenever there is something wrong. All right. So what I was trying to talk to you is like around the Kubernetes jargons, right? So what these Kubernetes jargons are, right? So any article that you read, you will come across. Everybody will say, okay, this is a node, this is a master node, and this is the worker node, and these are the workloads that you deploy, right? These are something which comes even on that it keeps hitting you, right? Any video or any article you see. But what are they, right? So basically, every node in a Kubernetes world is what you call as a compute, right? It's clearly any compute. It could be a physical machine, a cloud machine, or a virtual data center, or a data center within your premises as well. So that's what we call as hybrid cloud. So this could be everything. Could be what happens is that, so there could be everything when you see on my screen. I put this yellow price tag kind of thing, right? A label kind of stuff. So what they basically mean is that they are the ones which are everything in Kubernetes worlds are labeled. All right, so let's go straight into the thing. So let me go to the tutorial and then follow that from there. So to get to the tutorial, all you have to do is like you have to go to the slides. I mean, if you're there on the tutorials links, I put down the tutorial link there. So this is where we get started with. All right. So I'm just on the tutorial right here. I'm just going to follow the tutorial whole now, and then I'm just going to say what's kubectl view, right? So I said earlier, so kubectl is activated. So from now onward, what I'm going to do is like I'm going to do few things from this particular slides, which are onto the tutorial stuff. You're seeing my screen right now. So if you follow the slide, on the slide, I just told you bunch of jargons, right? We are just going to run few commands, run few demos and see what these things are, what these jargons mean, and I'll come back to that slide again, right? So that gives you a context how you can relate these objects as well. So let's go. The very first thing I need to do on my screen is like, I hope my screen is better. I have two clouds. Basically, one cloud is in Azure and one cloud is in GCP. So that's what I kept here, and then I have an application on my Kubernetes. So let's go, and the very first thing you need to do, the very first tool we need to do is get to kubectl, right? So if you go to the requirements on the installation, so we are given a bunch of tools that you can download and install that on your local environment so that you can run any part of this tutorial, right? All the part of tutorials follow this particular or use this tool in one or the other way. But as of this particular demo session, like next maybe like next half an hour or so, what you're going to do, so kubectl and stern and probably watch or HTTP, right? So other things are probably in Kubernetes. This is a very handy utility. It's not mandatory that, but it will always help you to do switch namespace. I'll show you an example also how convenient this particular tool could be. Okay, so once you go to use an OpenShift installation here, as I told you earlier, I have an OpenShift installation which is running on Azure. So that's why I'm in GCP. This is what I call as GCP here, just to name it comfortably. And then this is on Azure, right? That's going to be my Azure cloud. So one of the things what I want to highlight here is what we call as hybrid cloud, right? What advantage that OpenShift brings you. So OpenShift is again a Kubernetes cluster end of the day, but if you see OpenShift is kind of getting you this unified developer experience if you go to any cloud provider, whatever you want. For example, I'm on Azure. I'm seeing the same screen here. Okay, let me go to the topology view. Okay, the developer topology view. This is what developer topology from where the developers can deploy their applications, right? We are going to use CLI mode, but I'll also show you time permissions from here. So this is going to be on GCP. If you see here, I'm on GCP, Google Cloud Platform deployed there, and this is going to give you the same view. And when you go to Azure, so this is going to be Azure Cloud where I deployed OpenShift. Now if you see, I'm getting the same exact of your console. Okay, this is one of the biggest things which I call, what biggest features I call from when you're using OpenShift, is because if you, irrespective of whatever cloud platform you're moving in, I'm going to deploy my application as Kubernetes application. OpenShift is based on Kubernetes architecture. And since it's going to be Kubernetes architecture, any platform I deploy OpenShift on is going to give you the exact same look and feel. All right. So there's not going to be any change. All he has to learn is a bunch of Kubernetes commands so that he can deploy the application using Kubernetes. Other than that, he doesn't need to worry about what should be my underlying cloud command that I need to run, what will happen when I run on AWS, what will happen when I run on Azure, what will happen when I run on GCP, or any other cloud for that matter, right? So I have to learn a bit of those commands so that I will be very comfortable using that. Okay. Still, I'm not saying that you don't need those things, but OpenShift kind of hides those things from a day-to-day developer so that the day-to-day developer can just concentrate on what's required for him to deliver, that is application development and deployment. All right. So with that, so what we do is right now, let me go to my command, and then so let's go to the tutorial. I'll go by the tutorial and see what we have to do here. So I talked about briefly about the installation. You can read about the installation as well. So as a beginner, so that's the thing which you are doing, right? Like this is a very important environment variable that you need to be aware of. So let me go and echo this. So kubectl is the place where your credentials, your cluster information, and everything is stored. So it needs to be, probably don't share your kubectl publicly, because somebody knows that, then it's easy for them to get into the cluster because it has the certificates in it. So this is a very basic thing that everybody needs to know. This is a kubeconfig. I can set multiple kubeconfigs there as well. So one of the example here is, as I told you earlier, I have one OpenShift running on Azure and one on GCP, right? This is a GCP one. That's the reason why I have a kubeconfig created on GCP and it's available there. And let me go and do the same thing on another terminal. So, and then I say kubeconfig, or I'll just paste this command. I'm sorry. CLS echo $kubeconfig. And now this is pointing to Azure, right? In this way, what happens from the same machine using the same kubectl, I can talk to two different clusters very easily. End of the session, I'll also show you another easy tool that we have launched just a week ago, which is called Advanced Cluster Management in Kubernetes. I'll show you the link end of the day, which will allow you to do all these things graphically, deploy your cluster and maintain the cluster from within one single console. So let's talk. I'll talk about that a bit later at the end of the session. All right. So let's go back here. And then what next I need to do is, like, I know where my kubeconfig is. Another one which is very interesting for me is that how do you check the nodes, right? So let me go and find out how many nodes I have in my GCP cluster. All right. So this is where I was talking to you about the labels. So if you go back to the previous slide, the last slide which I had, I'm just going to go back to my slide for a second. And then if I go here, if you see the three blocks, right, of this one. So if you see the first block on the left, which is going to be having called as master, and this is having bunch of like etcd, scheduler, and API which are running on them, right? So this node, if you see, there's a tag to this thing, right? This is a compute again, all right? And if you have two other smaller ones, which I call as worker nodes, it could be one to many. So again, if you see, this also has a node, and it also has a bunch of products which is running inside that, right? It has a kube proxy, it has a k proxy, it has a PV, and few other things are called as nodes. Nodes are basically nothing but a compute where you deploy your applications on. All right. So that's what we're going to talk here about. So, but how do you identify what is a master and what is a worker node? So basically what happens with when it's a master node, what it does is, like, when you do an installation of Kubernetes or OpenShift in this case, so it knows that this is a master node. I have to go and run all these processes like etcd, scheduler, and API, which are the Kubernetes by the master. Right? When I say a node as a worker, then what basically happens, it goes and says, okay, I have to do this kubelet, k proxy, and bunch of PV persistent volumes. We'll talk about that a bit later. So I have to start running everything inside this. Okay. And what you see on the right side is just a blown up thing of a particular one node, right? It could be any node. So one worker node which is blown up and shown to you what all the processes that will be running inside this. We'll come back to this again after seeing some examples. All right. So let's go and see how do you identify a node, how to get the nodes within a cluster, and how to identify which is a master node and which is a worker node. All right. So, and you keep the point in mind. The one point you have to keep in mind is that they are all done using labels. All right. So using labels is what we are going to find out which is going to be a master node and node. All right. Let's go there. So let's go back to my command line, and then let's go to my tutorial, and then you'll see what we have here. So let's go. Kubectl get nodes is the simplest command which will give you all the nodes that is there in the cluster. All right. So I'm going to do like this, get nodes. Let's wait for a few seconds. And I should get a bunch of nodes back to me. So it's going to be with different one, right? If you see here, so this node is there. So one master node having a bunch of worker nodes, right? I'm going to have 5 worker nodes and 1 master node. You can have any topology. This one, the topology which you have right now is not an HA topology. What I mean to say here is that when something goes wrong with my master, your cluster is lost. Okay, but since it's a demonstration, I use this single worker node thing kind of thing. But typically, if you want to achieve an HA, minimum is you have to have 3 masters for the HA. All right. So let's go do the same and see what happens to Azure. So Azure should also give me pretty much the same worker thing, like same command going to return you exactly the same thing. It says, okay, they have here in this case, I have an HA. I have 3 worker nodes in Azure, and then 5 workers for the Azure and 3 masters. So this is going to be an HA configuration. What I have in GCP is a non-HA configuration, typically used for your R&D and other stuff. All right. So I know. So now, so this is no, but you will be wondering, like, what is the easiest way to identify which node is a master node and which node is a right? Also another way to filter this command. So that's what, let's go here, and then I'm going to say there's going to be labels going to fill up my console. So let me make my console little, and then I say CLS, and then I say show start node. I think this is going to show labels. So I'm going to get all the labels right now. So, but the thing is, like, it's going to be lots and lots of labels right now. If you see, there's a bunch of labels which is shown here. So if you see one of those labels, this is here, right? So this one right there, so cube node worker. So there's a label which does not have any value, which basically going to say, okay, this particular node has a role worker. Okay, that's how Kubernetes knows, okay, this is a worker node where I have to deploy my workloads and not run any master related processes. All right, so how do I get this? How do I query this? I can also query this thing like this. So let me go say kubectl get nodes. I have something called a selector. Okay, selector is nothing but I can query on the metadata of a particular Kubernetes object. One of the metadata for Kubernetes object is your label. All right, so label which is we checked right now as a worker, as a master, that becomes a bunch of annotations. Also, we can query on them as well. So the selector is basically works on your labels, right? So you'll see more about the selectors when you talk about service. And giving the nodes and saying, okay, I want all the master nodes, right? In this case, this is going to return me one master. And let me try this on Azure. So that's the GCP has one master. If we go and copy and paste the same command on Azure, I'm going to get 3 masters, right? So now what happens is that when you go and find the node is going to have master, and then its node is going to have these nodes, and this is going to be what you have. And what you can do the same thing with your OpenShift console as well. If you go to your console, and if you are an administrator, so if you can go to the administrator, and then once you go into the administrator, there is a compute thing, so which is there. So this one gives you all the information about machines. I'm not going to go deep into this because this is little bit higher, but this one, when you click on the nodes, this is going to give you all the information about this nodes, what this particular node, exactly the same stuff what we saw right now from CLI. But what we have done with OpenShift, we gathered everything inside and then showing you to via your web console, right? And this web console is kind of divided into two, an administrator and a developer, so that we can have the user with particular role attached to him, so that he can see only what is required from the administrator and what is required from a developer side of things. All right, let's click on this. So let's click on to one node and go and see inside, and you will see this one. There are a bunch of attributes here, and you have lots and lots of node labels here, right? So this is one thing which we also have. So if you remember when we talked about the constraints, right? When I want to say, okay, I have an application which is dependent on a database. So whenever I have to go and deploy my application, I have to go deploy taking along with the database, right? The node, the database is there. I'm going to go and deploy this there. So I'm not going to show the demonstrate the technique, but there is a tech node labels. When you run a kubectl commands, I can attach this particular deployment to go and sit in a particular node. Okay, that's where I can achieve, okay, that is the node, these are the nodes which has database in them. So go and deploy this application in any one of these nodes. Okay, I can just attach the selector, as we saw a selector, what you typed on the command line. I can just do the same selector and go and find this stuff as well. All right, so this is what we see. One of the things which you see here is like node role master. If you see this, there's a node role master here. So this is kind of helping you how to identify which is a master node. And then if you go, let's go and pick one, what you call a worker node, and then go find out what's there in the worker node here, and then find out, there we go, right? So we have a node role, which is going to be a worker. All right. So this is how we identify a marker, a master or a worker node here. All right. Let me take a quick pause to see if there is any questions around the nodes and the labels. So because it's very critical to understand this before we go further. I think the chat is pretty silent. I'm not sure. I made everybody sleep at lunchtime. All right. So, all right. So let's get back to the the tutorial, the way how to query the nodes, how to query the any resources with labels. So this querying with labels, right? The dash dash show labels. This is there for all your resources that you deploy on OpenShift. I mean OpenShift or Kubernetes, right? Which means that every resource can have a label so that it allows you to query by labels. All right. So let's go back to my tutorial and let's do this tutorial and see what we have on the tutorial. That's right. So we got there, we found out thing. Okay, this is a very interesting one, right? So get all namespaces, right? So this is going to get pods is basically we are going to get pod. Thanks, Abhi. I hopefully I did not make you guys sleep with a lot of talking, right? So I just want to make sure you're all awake. Okay, send you guys some virtual coffee on the thing. All right, great. So let's see about pods. A super critical thing. The pods is nothing but that's what your application, where your application is running. Okay, so for that I have to go back to my slides again before you see further on the pods. All right. So let me go back to my slides. What are pods, right? So if you see here, so I will go to the next slide, so which gives more details about this one, right? So pods are nothing but it can have one or containers are nothing but your Docker container images, that's Linux container images. Okay, it shares an IP. Every pod has an IP. It also shares the storage. Let's skip storage for now, and then it also shares resources with other pods, and each pod can talk with each other, and then it also have a shared lifecycle, right? Which means that any container which is within the same thing. If you're coming back to our Istio session, you will see a couple of more pods added into the same, a couple of more containers added into the same pod. And what is replica set and deployment? So these are the two critical things which you want to understand here, right? We are talking about, like, we saw one of the constraints when you deploy applications or microservices at any given point of time, I need to have my desired and actual count to be same, right? So which means that there should be some kind of a robotic mechanism that kind of takes care, that makes sure that my counts are always same. Keep watching, my counts are always same. That's exactly done by replica, right? When I have a replica set deployed, replica set deploys the pod. Once it deploys, now understand, okay, when the pod goes down or crashes for some reason, replica set knows that this thing up again. So we'll see that in a demo and when you do a replica set and pod in a second. But this is how Kubernetes maintains the desired and actual count. All right. And what will happen next is a service block. Service is basically what allows you the external things to access your service. Okay. When anything within a pod is concealed, within the pod can talk with each other, but when something outside the pod that has to talk with this containers inside the pod, then that has to go through the service. That's what service does. It groups the pods. And now, Prashant, can you share a link to basic commands that you are showing? Okay, so that is going to be there on dn.dev/cube tutorial. Okay, this is the link where you can find those commands. All the commands I'm doing right now are from the tutorial. Maybe it's not, maybe like I'll not do all the commands because that's for you to do the exercises, but I'm just going to pick and choose a command based on my context. All right. So, and service is basic. Now we understand one little thing here, right? One other thing which I need to explain now. So it's just a query. Probably I'll throw out the query on the chat. Maybe anybody can from the chat can answer me now. So how does a service knows which pod I need to send a request to? We saw some feature just now, few minutes back. So which plays a critical role for my service to find out which pods I need to send the request to. So anybody can answer. I'm not sure how we can give goodies over the virtual thing, but we'll find out a way soon. And then we'll discuss and find out a way so that we can send you the goodies as well. So one of the things I want, a good question from here, like is like, how do you find out, how does a service knows, how do I send a request to a pod? So I take maybe a 5 to 10 second pause to see if I get any answer. I leave my friend Sebi to grab the answers from the chat. But as you answer that, probably if you guessed it right, then it's always going to be using labels. Okay, so that's what labels is what plays a super critical role when you deploy a service. In few seconds, I'll explain how this works. So service is the one which will help you to kind of go and pick all the pods where I need to send request to. Okay, and persistent volume, end of the day, any application we develop needs a state to be persisted. That's what persistent volume. It's kind of a volume that could be mounted. It could be AWS, any kind of a block device could be mounted. It could be AWS GP2 storages, or it could be Azure storage disk, or it could be GCP disk. It could be any normal NFS volumes could also be mounted, but we don't recommend NFS for production, but for test, right? You can also mount NFS volumes as well. That's right, Abhishek. I think this is exactly on label. You're bang on. I think labels is what is becomes it's a very, very super critical feature of Kubernetes. Everything works on label. I think I saw Nick also answering on labels. That's great. I have Prashanta, kubectl get labels. That's great. I think Abhishek also answered that. I think probably I made a good job letting you know the importance of labels. Okay. And as I said, I still don't know the way, like how can I send the goodies, but we'll soon find it out. Maybe for the next Kubernetes master course, we'll find out a way by which we can have the goodies and raffles as well, right? So things make things more interesting. All right. And labels, as you saw the last, I think the last slide, probably I'm hiding the last one there. So probably I should need to bend down. It's a key value pair. It could be any kind of a key value, and we'll show an example as well in a second. All right. So let's go back to our command line and then query the pods. All right. So I'm going to go back to my command mode, and then let me grab the command and query the pods. I don't think so. From all namespaces, this is going to be a huge list of pods. But let's skip this one and come back to the get pods in a second after we deploy some stuff, right? So what I'm going to do next is, like, I'm just going to create a namespace. So where I am, let me see which project I am. Okay, let me go to the tutorial home. Okay. I'll also go here also. I'll just go to the tutorial home so that I can do the same command in every other stuff, right? The first thing, what I'm trying to do here is I'm trying to create a namespace. Okay, so if just when I'm running through the commands, if you can keep the jargons and the term slides side by side, then enable space labels and all of the stuff. So let's go to the namespace. So namespace is nothing but it's an organization of your services, pods, and other Kubernetes resources, right? It's done because I can have the same named resources residing in multiple places, just to avoid, as usual, when you started with the XML, we have this XML namespace and all these stuff. It's exactly the same thing here. I want to group my resources within particular namespace. In OpenShift, we go a little bit further. We call them as a project, where you can also assign quotas, right? This particular project can have only 1 GB of RAM or 10 GB of storage or something like that. That's what we've taken this namespace to next level shift, where you assign permissions and quotas as well can be assigned to the namespace. All right. So let's go and create a namespace. Let's go create namespace called as my stuff. Tab on time. I have 13 minutes more. So I hope I will finish before 30 minutes. So let me go and create this namespace. I have created the namespace called my stuff, and let me go. How do I shift the context? Right. So why do we need to shift this context? This is again another member in Kubernetes world, right? Once in a while it gets choppy. So now it's okay, Rudloff. I'm not sure. Probably there could be something related to the streaming thing as well. Is the sound better now? I'm just taking a pause to see if it sounds better. Yes, Ran. The voice is still interrupting. Okay, so I'll try to see what's wrong. I'm not sure. It's going to be my streaming app, or it's going to be YouTube. I don't know, or my network. I don't know, but my network is pretty good. I just found that. But let me try to figure that out next time. I'll make sure that it's not disturbing. Okay. All right. So maybe I'm kind of moving a little bit far from my mic, I guess. That's what is trying to fade. So I'll try to stay as close as possible. So what I'm trying to say right now is that so when you create a namespace, so we created the namespace and we've attached everything onto the namespace and we put resources within the namespace. So what basically happens right now is, like in Kubernetes, if you don't specify namespace, everything what happens is goes and deploys into the default namespace, right? And you will not notice that. Your application deployments will go fine. Everything will say okay, fine, etc., etc. Everything done successfully, but you will not see the sound. I mean, you'll not see the application. I'm sorry, since I was talking about sound, I said sound. You'll not see your resources getting listed or seen. That's just because, like, you'll be looking at the wrong namespace. All right. So that's what we're trying to do right now. We're creating a namespace right now. Kubectl create namespace my stuff. That's where I'm going to put everything on the my stuff namespace. And then what I'm trying to do next is kubectl config set context, which means in the current context wherever I'm in, which is my GCP cloud of OpenShift. I'm trying to go and set this namespace deployed without a namespace parameter. Go and deploy that into this particular current namespace called as my stuff. Okay, that's what I'm doing right now. Yes, every command has to be run within the context of OpenShift, Prashanta. From a local machine, since I'm connected to the OpenShift cluster right now, I can run all my kubectl commands just from a machine connected. I ran this one, I created this my namespace stuff. So right now I changed this one. If you remember, utility called as Kubernetes when you're starting the requirements. So I see this command for changing the namespaces like kubectl config context. Okay, I have a big command here. So what you can do also is like I can just do Kubernetes and then I say my stuff, and that's all I need to do. This Kubernetes commands, it also comes as a kubectl plugin. So this particular plugin can help you to deploy the command, quickly change your context with just a couple of options, right? I just say kubectl Kubernetes my stuff. It's going to do exactly same like my previous command, but only thing it's a shortened version of this command. It's just a handy utility for you because I put the earlier one to see just what exactly happens earlier. All right. So I've changed my namespace, and let's go and see what I need to do next. There we go, right? Our first on to Kubernetes, right? That's what we are trying to do next. Maybe guys would have already done Kubernetes, but this is how we create. We say create deployment. I'm saying so whatever the app, I can give a name to my application, and I'm saying which image I need to deploy this to, right? So I'm just going to say that, okay, go and pick this query.io is an external container registry like Docker Hub. That's from Red Hat. So you can just go and deploy. I think we have a bunch of images already packed. I'm just getting that image. I'm going to deploy this locally. All right. So if you remember something we saw about kubectl get pods, right? If you see, let me go to my browser. We saw here we get pods, right? Let's do this also. So I'll say watch kubectl get pods. So I'm just watching the pods on the namespace, and because since I am in an OpenShift cluster, when I execute the earlier command, it's going to list me huge set of things. So I'm just trying to avoid that to list only to this particular stuff, right? So let me go here and then say, so I'm just need to go to a different thing. Let's set Alex, okay, not here. Deployment. Let's type the command here. And then while go to my OpenShift console, I did that on GCP, I guess, if I'm not wrong. And then I'm going to go to my project called as my stuff. And there we go, right? So we have our application deployed in OpenShift. This is OpenShift UI view where I can see the same stuff which is getting created. And now it's running for you. All right. So now when I go and say kubectl get pods, I'm just going to go and create the command from here. Let's go and revisit our earlier command. Where is that? So that's going to be here. Not all namespaces. I'm not going to do from all namespaces. I'm just going to do from only from the current namespace. If I don't specify any namespace parameter, so it's going to get only from the current namespace. I think you can deploy it on any framework you want. Quarkus is just an example. You could go for any application. It could be Node.js, it could be Spring Boot, it could be anything it can deploy. So it's just an image which you used here in this demo. It's nothing to do with your Kubernetes microservices and Quarkus, right? There's no relation. But Quarkus makes you much easier. So if you come to our Quarkus sessions next week, we'll show you what's the difference we are making with that. Okay. So now if you see, I have one pod which is running right now, which is called as my app. It's the pod 6 and then some auto-generated value to make it unique. Then it has one of one, which means that there's only one container running. There's no restart. Its status is running. All right, running for 42 seconds. All right. So let's go and find out what labels it has. Let's go to the same command and then show labels. All right. So we're going to get the labels right now to find out what labels we have. Still running out of time. Is 6 minutes more. If excuse me if I extra because I just want to show a few more stuff which will help you to go back and run the tutorials as well. So now if you see equal to my app pod template, hash, something like that. All right. So this is a way by which I can deploy the labels as well. I have bunch of other labels which is running here. And then like this is how your service is going to identify the thing as well. So let's go next. We'll see what we have right now. Let's go down and probably let's skip the events. So probably what you can also do is like you can also watch the events. The events is basically nothing but everything that has an event is generated, right? So for example, if you go and watch the events right now, there will be a bunch of events reported. So one of the events might be all my pods created, right? For example, I have created my stuff, successfully pulling the image, successfully pulled the image, created the container app, scaled up the container replica set to 1. Okay, you see every of the events. So events becomes very important when you're running with Kubernetes, because sometimes there might be errors. Your container might not be deployed correctly, your application might not. It will be very handy that we can go with the replicas or replica sets or the events to go and find out what's gone wrong. Okay, this has gone wrong in this. So let me go and get this one running. So if, okay, for example, it might be misspelled your image name, pulled, your application will not be started. Okay, these are a few examples where you can go and find out what exactly happens within the events. All right. So you talked about pods and over there. We saw about these things, the replica says and other stuff. And then let's go and expose the service. So how do I call the service from the external world? So so you can also see the logs, or the application logs are from here. This is from quay.io. So Prashant, I think everything comes from quay.io. Why? I just typed out on the chat. That's the thing from where I'm getting these images from. So let me go back here and then do exposing load balancer. What does it mean? Since my Azure cluster is running on an external cloud, so I have to expose I have to get a public IP so that I can access this application from the external cluster. That's exactly a balancer. With a load balancer, what happens is that when I say kubectl, as like what we got pod, we can also get the service using get svc command. When I put svc, it is going to give me the service that has got exposed just now, the my app service. And since it's a type is load balancer, it still says the external IP is pending, right? Since it's going to be an external application, it takes fractionally bit of seconds to get an IP. And then once we get the IP, the application gets exposed there as well. I can call the application. Let me try to call this again to see if we got the IP. Okay, still waiting. So we'll come back and check in a few seconds to see what IP is there, right? And what else we saw here? So we saw the pods that show labels, and then I can also, using the labels, I can also go find out the logs, right? For the whatever. So usually what happens in the container world, we'll not write to log files, we'll write to the std out, so that when the application is running, the application can go and find out what's log. For example, this is a Quarkus application. This says that it's running and started on 8080, and whatever the logs your application is going to throw, is everything is going to come via kubectl logs. Okay, kubectl logs, I can either use the selector as app name, I can get the labels and get it, or I can use a pod. So let's say kubectl and kubectl get pods, and then I have a bunch of pods here. So I can also do like this. Okay, so kubectl get pods, and then I say kubectl kubectl logs -f is for follow, like as you have in Linux or Unix, and then I can just follow will not terminate. Now I'm getting the explicit logs from a specific pod. That's what I'm going to do. It's going to return you exactly same, but now I'm using a pod name. Either I use pod name, or I can use a label or anything which is specific for a pod you're querying the logs for. All right, so let's go and check if we got the service back. So get service. I guess we should have got the IP address. All right, let's go and check if I got the IP address now. Yeah, there we go. Right, we got the IP address 35 blah blah blah. I'm just going to copy this from here and then say curl. I think I'm on 8080, and then say slash. There we go. Right, so you call the service which was deployed there. It says supersonic subatomic Java, which we deployed there, and then we are calling the service directly using the port. Right, we are exposed as type load balancer, and then we are kind of got the service back with this. All right, So we saw about all these things here. We can wash get services to get the address and every stuff. All right. So we just query the service as well just now. Another important thing, we have talked about replica sets, right? That's where you go to scale the app now, right? So if you watch the if you watch this particular one, so let's go and do it from the console thing. This particular app. Now when I go here, I have something called as edit count. So what do you have? One pod running right now. I'm just going to say 2 pods and then save. Now what happens is, this is how I scale the application, right? I can do the same thing from the command line as well. I'm just showing you how easy to do that from OpenShift, because I can just go to the console, click on the app, and then click on the edit count and then increase the count, right? How many ever counts I want. Now what happens, my application is right now running with 2 replicas or called as design. Now the actual count, the design count, all same. Okay, let's do a quick thing. So let me also go and change this here. So let me set dot cloud profile. I'll just change this one quickly. Just change this to GCP so that I can be on the same cloud. And set dot alex kubeconfig. Okay, so I'm on my stuff. I'll say watch pods. Watch kubectl get pods. And the interesting thing which you want to watch here is, I said one of the constraints which you talk about, right? The application orchestrator should take care of having the actual application state different. That's what I'm going to do now. Kubectl get pods. Okay, we have 2 pods right now. And what I'm going to do is, like, I'm just going to delete one pod. Delete pod. I'll copy this 64C79 and then go there. And then say delete pod. All right. When I say delete pod, the pod gets deleted. But thing is, like, since there is a replication set controller which is running behind the scenes, which is taking care of the stuff, which is looking at the stuff, you'll soon see there's one more pod which will come up quickly. Okay. So now I deleted. You see this? Since I've increased the replicas to 2, the replication controller by default takes care that these 2 pods, there is always 2 pods is running for my application. So whenever something deletes or your pod crashes, it brings it back to its original state. All right. So that's what we see here. So that's what is the scaling of replica is all about. So I showed you scaling from the OpenShift console, but you can also do the scaling from the command line as well. So let me go and find out the command if we have to show scaling for you. And this is just to run the multiple times. There's an implicit load balancing which will happen right now. So let me go here. So while true, it's frozen. I don't think so. I think it's still moving up, Boris. I say while true, curl. Say I need to go grab the IP address of this, so I'll just go do this. Curl command and then say copy this address and then sleep.3 done. Okay, so I think it's end. Okay, now we'll see this. Now it's distributing between these 2 things, B857 and L8NKS. So because that's the implicit load balancing that Kubernetes gives you, because it goes and queries all the available pods, and then it kinds of goes and lists you, gets the output from those commands, and then start pouring it down. Okay, that's what it's doing. It's doing here, right, in this case as well. All right. So this is the service distribution load balance that's using labels again, and it goes and queries the pods by labels and then gets it for this. Right. So if you go kubectl, what service does pods? I have a selector equal to app. I think it's my app if I remember correctly, my app. So when I query by this thing, I'm sorry, my command is wrong. I should get 2 pods right now. So that's what your service also does behind the scenes. It goes and queries those 2 pods and it gets the output alternately doing the round robin mechanism and then distribute the traffic among those stuff. Okay. So that's what is a service load balancing stuff which you saw here right now. And then we saw, and then you can also, as I said earlier, I can also increase the replicas from the command line. Okay, so this is what I'm going to do right now. You saw that I did it from console. Right now I'm doing it from the command line. I say scale deployment, my app, replicas equal to 3, which now what happens, my replicas will now bump from 2. and then you should soon see the third one coming up on the kubectl get pods here. There we go. So we get this kubectl thing right there. So you can just go and start doing this stuff. I think I've taken 10 minutes, 4 minutes extra from thing. I think I'll take few more minutes. This is what a service magic which I explained right now. So we saw the service magic and deployed, and then I'll show you how we distribute the traffic. And one of the things which you see here, so if you see the selector, so this is what matters, right? So for example, like, so let's go and do this one for the existing service. So let me go and get it back. Kubectl, edit, edit SVC, my app. So when I edit the service, I'm going to open the service in my editor, which is going to be on a VS Code editor. I'll show you a little bit stuff how the querying happens right there. So if you see this one, so there's one important stuff which is called a selector, right? So you know that my app. So let's go here. Let's do a quick comparison as well. So let me go say kubectl edit deployment my app. Okay, I'm going to open both the stuff in the same thing side by side so that I can show you how this service magic happens behind the scene. All right, so let me put this on this tab, and I'll put this on this tab. Control KP. If you see this for the deployment, what I'm trying to do is, like for pods, I'm trying to go and specifying a labels, right? This is a template spec which basically tells what will be the template of my particular pod, what should be the container image, resources, etc., etc. So you'll see about resources in the advanced section. Now, one of the critical thing here, what we say is the labels, right? This is what happens when I say kubectl get pod show labels. This is what and I want my service to go and interact with this particular pod and get the output from this particular container's output, then this is what I need to do. Now I need to tell selector app equal to my app, and then now it goes and maps these two things and gets the service problem, right? That's what happens to us when we ran this thing curl multiple times earlier. You saw that it was round robining between this particular app, because when I query by label, I got two pods, so Kubernetes automatically does a load balancing between them. All right. Is a service similar Docker file in a service similar? No, it's not. It's not. There's nothing to do with the Docker file and the service here. The service is nothing but it's going to get you do a round robin among the pods and get the services and outputs from bunch of pods together. So this Docker file is just an image, right? What you do, build an image. That's what is this. The Docker file has nothing to do with service. All right. So this is how. So that's the reason why. So when you are doing your very first Kubernetes deployment, or even very last, even now I do the same mistake. Even if you're a seasoned user, is that you'll try to deploy a service, you'll try to deploy a pod, and now what we see is that we'll see the service is not giving you the right response. You are not getting the response from your service, probably because your pod labels might have been mismatched. Okay, so be sure that the template within template, the labels here is exactly same labels that you give within your service selector. All right, so this is very important. Just keep in mind, this is how your Kubernetes queries your services, service pods, and then distributes the traffic amongst those pods. All right, so let's go back here and see. I'll just take 2 more minutes before I close it out, and then this is what we have here. I have the pods, and then this is what we saw here. We saw the service, probably saw the service deployment. I think that's pretty much I have for the day. Probably we'll talk about building images, resource limits, and other stuff. Once we get back to the thing in the next week, we'll continue from where we left out. Day after tomorrow, where we have another master 2 session where I'll talk about other things like building images, setting resource limits, and do other stuff, and probably some more questions which you might have from today's session. All right. So before I say goodbye, and thank you so much for bearing with 12 more minutes, I want your help to fill out the survey. So I'm just going to put the survey link here back on the chat. So this is going to be the survey link. I'm just putting that on the chat. Okay, so how do I get there? Okay, so I'm just going to think Sebi, do you have the survey link? I'm just going to copy it. Okay, I'm just going to copy the survey link before I close the session. Let me go here, and then I'm going to copy the survey link. Survey link right there, and then I'm just going to copy the one for the day. One for the day goes here for you. So please do fill this survey link. I know about there are certain glitches. Probably, I think I went too far behind from my mic when I was speaking. Probably a little bit more excited. Okay, so probably I'll try to avoid that throttle off next time so that like you can hear me well. And this is the link which I have, which I put on my chat. I think that's pretty much I have with the basics that needs to be covered. Probably, I would request you to come back to my session again next week. I mean, sorry, not next week, couple of days after, where we are going to talk more about other features like more about services, more about deployments, and more other pieces that we have here. So there is no free account with OpenShift as of now today, Prashanta. I think if you have a cloud credits, then you can get down to try.openshift.com to get your cluster app. This is going to be try.openshift.com. You can get your if you have a cloud account, then that's enough for it, so it can go there and take it from this. And I hope it was pretty helpful. Maybe like we can cover more ground probably in the next session on Thursday. Until then, thanks for joining my session. Have a wonderful day ahead. Goodbye.